Το πρόγραμμα είναι κατάλληλο για άνω των 8 ετών. Our memories shape us endlessly, day after day. They allow us to mature and grow in light of our acquired experiences. By bringing the past to the surface, memory reminds us at every moment of who we are. But our memories have a dark side. Like dreams, memories are often distorted versions of our actual experiences.
One of the things that we have learned about memory is it doesn't work like a videotape recording. It's more like a Wikipedia page. You can go in there and you can edit it.
One interesting thing about false memory is that it's hard to know when you've had a false memory because you think it's right.
It's a disturbing secret hidden in the dense labyrinth of neurons in the brain that laboratories around the world are trying to bring to light.
In order to modify a particular memory or to retrieve it artificially, we need two things. First, we need to be able to find the memory in the brain. And second, we need to be able to manipulate it.
Our memories are unstable, impressionable. And today, scientists are actually able to manipulate them.
On peut prendre un souvenir et pendant le sommeil, on peut le rendre agréable ou désagréable.
I can probably create a artificial false memory in your mind. In other words, I can brainwash you. But of course, we don't do that.
Should we worry about these findings? To what extent can we trust our most precious memories? Why do our own brains distort the truth? Welcome to the disconcerting world of unreliable memory. Our investigation into the fickle nature of memory begins just south of Los Angeles on the campus of the University of California, Irvine. This car, which seems straight out of a Hollywood B-movie, belongs to the captain of the Scientific Brigade of False Memories. Elizabeth Loftus was the first to uncover the problem of false memories. This was in 1974. Since then, she and her team have been on the case. The way she sees it, all memories are suspect, especially those from childhood. If you cherish your own, don't listen to what she has to say.
When I look at this one, I can see that I am with my baby brother, and he was born, and so maybe I was 2 years old or 2.5 years old, and I just don't have any memory of that. And then here I can see that I'm with my two brothers and my cousin, but I don't know if that's my earliest memory or not. Well, people as adults do not have reliable, concrete memories for things that occurred in the first couple of years of life. There's a phenomenon called childhood amnesia, and most psychologists would put the offset of childhood amnesia at about maybe age 3 or so. The brain is continuing to develop, and you need sufficient brain development to store long-lasting memories. And maybe that happens at about age 3.
But in that case, where do all these images in your head come from? You've reconstructed them simply by looking at your family album or listening to the stories your parents tell. And as unpleasant as it might seem, your most recent memories are also riddled with approximations, inventions, mistakes, and false details added after the fact. To study this phenomenon, Elizabeth Loftus has become a manipulator, an expert in the falsification of memory. Her technique? To contaminate memories with false information. In her laboratory at the University of California, she discovered the Bugs Bunny effect. To participate in the experiment, the only condition is that the subject needs to have visited Disneyland in their childhood.
So the first survey we have you doing is just kind of like a quality survey for Disneyland. And we're just interested in hearing about any of your experiences at Disney. So have you read through this advertisement, and then when you finish reading it, a next button should appear down here and you can just continue.
So it's 4 p.m. on a hot breezy day. As you pass Toontown, you spot Bugs Bunny, your hero, who waves you over. Adrenaline rushes through you.
The poster is a fake ad.
The perfect
Bugs Bunny doesn't belong to the Disney universe. Influenced by this false information, the subject is asked to answer questions about their memories from their real visit to Disneyland.
Kevin, I'm done.
Okay, so we can walk outside, and then you can just have a seat over here. We showed you an advertisement for Disney, and it featured Bugs Bunny, and then we asked you if you remembered interacting with certain characters while at Disneyland. Now, you said that you met Bugs Bunny at Disneyland, but Bugs Bunny is a Warner Brothers character. Bugs Bunny has never been at Disneyland. So that's just an example of how, by even giving people just the smallest suggestion, right, just by showing them an image of Bugs Bunny in an advertisement, we can make them remember something that we're sure never happened, right?
Yeah, so it's like planting false memories.
Right.
When we succeeded in getting people who said, oh yeah, I remember, I met Bugs Bunny, I shook his hand, I touched his tail, I heard him say, what's up, Doc? We knew they had to be remembering something that was false.
This is not an isolated effect. Even our most personal memories are vulnerable to contamination, as shown by the hot air balloon experiment. 4 childhood photos are provided by the family, but in one of them, a photoshopped image has been slipped in, the subject in a hot air balloon alongside their father. One out of the 3 subjects is fooled and claims to remember the event. Some even remember what the weather was like on that day, which in fact never existed.
I mean, there is a lot of fiction that's sprinkled in between maybe those otherwise basically authentic memories. And it makes people uncomfortable to think that that they can't count on their own memories.
Don't think you're immune to false memories. They intrude constantly, affecting all of us. The reason? The functioning of the brain, probably the most complex machine ever invented by nature. We're only just beginning to understand the mechanics of memory. The process begins with our sensory experiences, the things we see, hear, or feel. This information then gradually converges towards the hippocampus, which is like a storage container for our perceptions. The hippocampus processes information from the outside world and then redistributes it to the memory's attics. These attics are spread throughout the brain, which makes them very complicated to study. The information is stored in small packets of neurons that are basically interconnected. So, what form do our memories take? Where exactly do they live? These are the questions asked by researchers today. The only thing that's certain is that our hippocampus also works in reverse. At the moment something is remembered, it awakens the neurons in our memory and projects the memories into our consciousness. This process is sophisticated but also fragile. It plays tricks on us. It can generate false memories. Daniel Schachter, one of the lieutenants of the Brigade of False Memories, has set out to catch our brains in the act of falsification by using brain imaging. Because MRIs don't lie. But he doesn't want to attempt this with our childhood memories. It would be too complicated. As often when it comes to science, you have to simplify the basic facts.
I'm going to take you into the scanning suite now, and we're going to put you into the MRI scanner. Probably the most important.
Daniel Schachter and his group at Harvard have scanned many brains in their examination of the false memory problem.
That's really important. And now I want to introduce you to Tammy, who is going to take you into the fMRI scanner.
No lie detector here, but a kind of false memory detector. Through brain imaging, he hopes to see the brain make mistakes in real time.
Okay, we're ready to go now, and we're going to show you a series of geometrical forms on the screen. And what I want you to do is pay close attention to each form as it comes up, because later on, I'm going to ask you some questions about them.
The idea behind the experiment is simple. First, the subject has to memorize a series of geometric shapes that are intentionally very similar and confusing.
Okay, now it's time to test your memory. I'm going to show you some more forms, and when you see a form that you think you remember having seen before, say old. When you see a form and you think you didn't see that before, say new.
It's hard for the subject to distinguish between already memorized shapes and new ones that look very similar. But this isn't about measuring memory performance. The experiment is more sophisticated than that. It enables the scientists to observe what's happening in the subject's brain without the subject knowing, especially when the subject is wrong, when they confuse the real shapes with shapes they've never seen.
So here we're looking at a part of the visual cortex in the back of the brain, located back in here in the occipital lobe. And these regions of the brain showed more activity during true recognition when you remembered a form that was really on the list as compared to false recognition, when you falsely remembered a form that wasn't there but looked like other things that were there. And these parts of the brain are involved in processing visual information. And of course, it makes sense that there would be more visual information about a shape that you actually saw earlier than one that just looked like what you saw earlier.
So the brain knows the difference between a true and a false memory according to the scan, but it distinguishes a right from wrong without our knowledge. Why aren't we aware of this process? What creates the confusion between true and false? For Daniel Schachter, the answer is also in brain imaging. He discovered that our consciousness couldn't easily tell the difference between real memory and imagining something close to real. In both cases, the same areas of the brain are activated. The root of the memory problem is perhaps located here.
Memory has a lot in common with imagination. Remembering and imagining are very similar. When we do brain imaging studies and we ask people to remember past experiences, or we ask them to imagine something that might occur in the future, what we see is that many of the same brain regions are involved, including, for example, the hippocampus. So the overlap between brain activity for remembering and imagining could explain some kinds of false memories.
So our brains are guilty of substitution, capable of confusing imagination and memory. How is it possible that millions of years of evolution have not led to a more reliable memory machine? A computer stores billions of data without error. Are we doomed to be betrayed by our own brains? Pascal Roulet, a researcher at the University of Toulouse, has been probing the cause of this imperfection for years. He made an amazing discovery. We make changes to our memories when we use them. Remembering modifies the memory. He calls this the Marseille fisherman syndrome.
On va prendre un pêcheur, il prend un poisson de 10 cm. Donc, il va mémoriser l'information, j'ai pris un poisson de 10 cm. Le lendemain, si quelqu'un l'interroge sur ce qu'il a pris la veille, comme il est marseillais, il va avoir tendance à exagérer un petit peu. Donc, il va répondre 20 cm. Le problème, c'est qu'il va mémoriser l'information initiale plus l'exagération. Donc, il va mémoriser en mémoire à long terme un poisson de 20 cm. Quand une semaine plus tard, on va lui demander qu'avez-vous pris il y a une semaine, il va se souvenir d'un poisson de 20 cm. Et comme il est marseillais, il va rajouter un petit peu, et donc ça va faire un poisson de 30 cm. Et il va stocker cette information de nouveau en mémoire à long terme. Donc ce qui est intéressant ici, c'est qu'il y a une évolution progressive du souvenir. À chaque fois qu'on va réactiver le souvenir, eh bien, on va ajouter des petits éléments, et le souvenir initial et le souvenir final peuvent être très différents.
Whenever we remember a situation, a new detail or modification is likely to slip into the memory. 15 years ago, Pascal Roulet and other researchers discovered an explanation for this strange phenomenon. A memory becomes temporarily fragile and malleable when it is brought to the surface.
Alors, lorsqu'une information arrive dans votre cerveau, cette information va être consolidée pour créer un souvenir. Ce qu'on a découvert dans les années 2000, c'est lorsqu'on rappelle ce souvenir, il remonte à la surface et il devient fragile. Ce souvenir fragilisé va pouvoir intégrer de la nouvelle information de l'environnement, et pour être stabilisé de nouveau en mémoire, il doit subir le mécanisme de reconsolidation. On a donc ici une fenêtre temporelle où le souvenir peut être modifié.
The weakening and reconsolidation of memory are totally unconscious phenomena. In fact, our memories are transformed without our knowledge. So, how can we trust a first-hand testimony, even from an honest person?
But actually, those two witnesses were the entire case for the prosecution. Supposing they're wrong.
What do you mean, supposing they're wrong? What's the point of having witnesses at all?
Could they be wrong?
What are you trying to say? Those people sat on the stand under oath.
They're only people. People make mistakes. Could they be wrong?
Well, no, I don't think so.
You know so.
Oh, come on, nobody can know a thing like that. This isn't an exact science.
That's right, it isn't.
I think the false memory problem in our society is a really big problem. And one of the reasons that I'm convinced of that is in part from the cases of wrongful conviction that have now come to light. There are hundreds and hundreds of cases of people who DNA testing has now been done on their case material, and it has proven that they're actually innocent. They spent 10, 15, 20 years in prison for these crimes that we now know they did not do. When you analyze those cases, what led to the wrongful conviction, the major cause is faulty memory.
An honest witness does not guarantee a truthful testimony. False memory has always plagued the justice system. To overcome this problem, the National School of Magistrates in France has implemented a workshop focused on the reliability of memory. The goal? To educate future judges about the false memory problem. They watch a murder scene. Then it's their turn to play the role of witness.
Voilà, la projection s'arrête là. Je vous invite à rejoindre les salles. À tout à l'heure.
Students are then divided into small groups. Each one will testify about what they saw.
Je peux uniquement vous indiquer à ce stade que vous êtes le témoin qui a prévenu les services de secours dans la scène qu'on a vue et qu'à ce titre, vous allez être entendu par les services de police.
Mais j'aimerais en tout cas, dans un premier temps, que vous me décriviez physiquement cet individu qui a tiré sur la dame.
Il était brun avec les cheveux courts. J'avoue que je n'ai pas du tout prêté attention à sa tenue vestimentaire. Je dirais qu'il avait le teint plutôt hâlé.
Combien de tirs avez-vous entendu ou vu?
Deux. La personne rentre, pointe et tire.
D'accord. Et ces tirs étaient-ils espacés?
Non, il les a tirés de façon... C'était pas... Enfin,
très bien, papa.
Voilà.
In this room, the witness is doing fairly well, but you'll see this is not always the case. Between the frequent omissions, not to mention pure and simple inventions, there are as many different testimonies as there are witnesses.
Jean noir, au blanc, au noir, sang, bleu, rouge. Et on en a 4 mattes de peau ou tout maghrébin aussi.
You heard right. Some of the witnesses thought the suspect looked North African. Others thought he was wearing a black jacket, far from the reality.
Pourquoi certains qui voient là un blouson noir, tous les ans on a des blousons noirs, alors que le monsieur porte une chemise rouge à carreaux.
For this psychologist, a specialist in memory, it's not a surprise. Stereotypes, prejudices, assumptions, preconceptions are constantly slipping into our memories according to a well-known psychological effect.
Quand le suspect a une arme, donc un pistolet, et braque sur la victime, là, il y a un focus sur l'arme. Donc toute l'attention va être focalisée sur l'arme et le témoin va zapper toutes les informations périphériques, même l'aspect physique du suspect. La mémoire n'a pas le temps de tout enregistrer. Et sur ces manques en fait, d'informations de la scène, rapidement, elle va être comblée par nos connaissances, notre expérience, nos stéréotypes. Je donne un exemple. Dans une vidéo, nous avons montré que c'était une femme qui braquait, alors que le témoin a rappelé plus tard que c'était un homme. Donc ça va jusqu'au sexe et bien sûr à la couleur de peau.
A witness's memory spontaneously fills in missing information with information that seems coherent to them based on their own prejudices. A testimony is always subjective. And for now, the legal system is forced to make do with our imperfect memories. So are we condemned to suffer at the whim of our faulty memories? Could we improve its imperfections? Eliminate the stereotypes and prejudices that creep in? Maybe someday. But to get there, first we have to understand how memory works, including its most hidden functions. This is the challenge for scientists worldwide as they take on the study of microscopic neurons. For this mission, the Japanese Office of the Brigade of False Memories in Sendai has recruited a surprising new informant, the fruit fly. Distinguishing feature, an excellent memory for such a tiny brain. It contains 100,000 times fewer neurons than ours. An ideal scale for understanding the mechanics of memory.
To understand human memory, it's extremely complicated, of course, and the brains are very complicated, and the memory we are talking about is also very complicated. So we need a very simple system, and that's where Fly can contribute.
Hirono Tanimoto is one of the few scientists in the world to have successfully implanted an artificial memory into the brain of a fly.
Well, it may not be that obvious, but the flies have a brain, and it's a very efficient brain, and they can form a very good memory. So this is my lab, and you can call it, this is like a fly school, let's say. For example, this room, we test a fly memory, and you can call it examination room of the flies. And in this room, so we teach the flies, so it's like a classroom of the flies. And as you can see, we have to keep the flies very calm and dark. This is the dormitory of the flies, and there are many, many mutants are there. So many different students, let's say. For example, this one, very important. This is the fly where we create an artificial aversive memory.
Students in this rather unique school have a busy schedule. They spend their lives in a teaching machine under the guidance of Professor Tanimoto.
This is the teaching machine, and here's the flies. I aspirate the flies and collect flies and bring them into the choice training tube, which is here. Now I blew the flies in the training tube. Here's the fly. Okay, now flies receive an odor like this. And then I give a shock, electric shock. So now flies are receiving an odor with electric shock at the same time. So this odor becomes, so flies may form memory that this odor is bad. And now shock is over. I take out the flies like this and bring them into the choice test tube. So the flies are here, and then I bring the flies into the choice point by moving this machine.
The choices are simple. In the right tube, the odor previously associated with the electric shock. In the left, another smell unrelated to the unpleasant memory.
Now flies are making choice, and if they remember which odor is punished with electric shock, they should avoid this odor. Consequently, you can find more flies in the other arm of the maze.
So the combination of shock and odor results in the flies fleeing to the side that doesn't have the odor associated with the trauma. The flies are able to keep this unpleasant memory in their minds for more than a week. Their memory is certainly rudimentary, but it's easy to measure. Just what's needed to study the functioning of their brains. With this state-of-the-art microscope, it's possible to see tiny neurons activate in the fly's brain. By examining the labyrinth of brain cells, Hiromu Tanimoto was eventually able to identify the neurons involved in the perception of the electric shock. But more importantly, he managed to take control of these neurons in the fly.
What is even more striking is that we can manipulate this single neuron in the freely behaving flies, freely moving flies. We can block or activate this very small subset of aversive neurons.
So Japanese scientists are able to hack the brains of flies, creating the perception of electric shock on demand by triggering the right neurons. This occurs without subjecting the fly to any real trauma. An amazing technological feat made possible by genetic manipulation. If an odor is presented to the flies at the exact moment that the neurons are artificially activated, they associate the fake electric shock with the actual odor. This odor is now a danger signal for the flies. In fact, the smell activates nothing less than an artificial memory, a trauma that never took place. Playing with the neurons gave the flies the illusion of an electric shock, and this became an unpleasant memory for them. The proof? When the flies are exposed to the smell again, they try to avoid it. For Professor Tanimoto, creating artificial memories is not an end in itself. It's above all a concrete demonstration that memories can be made by tampering with neurons. He's pinpointed a building block of the memorization process, or what is called associative memory. Certainly a key to understanding the workings of our own memory.
We have identified is the basic mechanism, cellular mechanism that drives associative memory. And we human, for example, use this associative memory very often. So this is a very important component of the brain function in all brains. And that's why we think that the simple mechanism we have found may be applicable and even comparable to understand human brain.
So hacking into the neurons of laboratory animals allows us to highlight a fundamental process of memory, association. Around the world, other teams are using the same strategy to test different features of memory and with the help of different suspects. The Brigade of False Memories created an office in Paris at the National Center for Scientific Research. Karim Ben-Shinan joined the team on a crazy hunch. He was convinced that to implant an artificial memory, the intervention must happen while the subject is asleep. It was 2 years before the release of the film Inception, in which the main character, played by Leonardo DiCaprio, enters people's dreams to toy with their memories.
Karim, tu peux venir, s'il te plaît? Je vais vérifier les signaux, mais à mon avis, on a une bonne cellule de lieu. Là, on a des repères, donc on est bien placé. C'est ce neurone-là? Ouais, tout à fait. C'est voilà, j'ai identifié une cellule de lieu. On va déclencher les stimulations pour le faire.
The truth is that it's not easy to plant an idea in the brain. Before accessing a mouse's dreams, Karim and his team need to know what's going on in its head when it's awake.
C'est bon comme avant.
Je te laisse installer la souris dans l'environnement, mais je vais vérifier ici.
So, thin electrodes have been implanted in a specific region of the brain, the hippocampus. This is where the spatial memory cells are, a kind of internal GPS that helps the mouse navigate, memorizing the layout of places it enters. Scientists call these neurons place cells. This device shows the activity of these neurons on the screen.
Donc là, en fait, on regarde la souris, on est capable de voir la position de la souris en temps réel. Et ce qu'on entend, c'est l'activité d'un neurone. On sait que ces neurones déchargent quand l'animal est dans une position particulière de l'environnement. On pense que l'activité de l'ensemble de ces cellules de lieu forme une carte cognitive. C'est comme si on avait une carte à l'intérieur du cerveau et certains neurones déchargent quand on est à une certaine position dans un environnement. Et d'autres neurones déchargent quand on est dans une autre position. Il faut 5 à 10 minutes pour que cette carte des cellules de lieu se forme. Et une fois que cette carte est formée, ça représente la mémoire de l'environnement pour la souris. Et en fait, on pense que le neurone décharge quand la souris est dans le champ de lieu ou quand elle y pense. Et en particulier, on travaille plus précisément sur le sommeil. En fait, on s'aperçoit que le même neurone va pouvoir décharger pendant que la souris dort quand elle réactive, ou pour simplifier, quand elle rêve de l'endroit dans lequel elle est.
By overlaying the electrical signals of day and night, scientists can track the mental movements of the mouse and pinpoint when it dreams of the orange cube's location, for example. Then, the researchers take it further. They implant a second electrode in the reward circuit of the brain, an area linked to pleasure. When the mouse dreams of the orange cube, the scientists artificially trigger an intense feeling of satisfaction. For the mouse, it's as if it was dreaming of enjoying a huge piece of cheese in that location.
Donc là, on vient de la réveiller et on va regarder où elle va effectivement. Donc elle est un peu endormie.
Once awake, the mouse goes straight to the orange cube as if looking for a reward.
Donc en gros, c'est comme si on lui avait inculqué pendant son sommeil le souvenir. Ici, il y a une récompense.
can these experiments conducted on mice be applied to humans? Like in the movie Inception, will it someday be possible to enter our dreams to implant an idea or change a memory? Professor Jan Born's research shows that it's indeed while we sleep that our memory is at its most vulnerable.
Schlaf ist nicht nur ein passives Moment in diesem Gedächtnisprozess, der also schützt die neu aufgenommenen Informationen, sondern ist ein aktiver Player. Insofern es gezeigt wurde, dass im Schlaf, und zwar im Tiefschlaf auf neuronaler Ebene, die frisch aufgenommene Information reaktiviert wird. Eine Art Replay findet im Tiefschlaf statt. Und dieser Replay, der unterstützt nun tatsächlich den Transfer der frisch aufgenommenen Informationen von diesem Zwischenspeicher in den Langzeitspeicher, der da im Neokortex sitzt.
Hallo, herzlich willkommen. Bitte nach Ihnen.
Jan Born's team has pinpointed the precise moment when sleep transforms learned information into memory. Using a simple EEG, researchers can identify the brain waves that represent the day's events as they're being stored.
Jetzt bringe ich EEG-Elektroden auf Sie an, mit denen wir dann später die Verhältnismäßigkeit messen können. Dies ist besonders wichtig, damit wir die verschiedenen Schlafstadien unterscheiden können, die Sie in der Nacht aufzeichnen werden.
The experiment helps improve the quality of memories created during sleep.
Das EEG ist im Hirnschlaf genauso wie im Wachzustand.
Absicht. Hotel.
The subject performs an exercise memorizing word pairs right before going to sleep.
Expulsion.
Zu guter Letzt haben wir jetzt hier noch die Kopfhörer, die Sie bitte einstecken können. Sie brauchen halt, damit wir Sie abends halt dann in Tiefschlaf stimulieren können. So, dann würde dann jetzt das Experiment beginnen. Ich wünsche Ihnen eine geruhsame Nacht.
For this experiment, the scientists have hypothesized that memorization would be improved by a sound pulse that can amplify the brain's oscillations during sleep. To achieve this, however, the sound pulse must be triggered at just the right moment when what was learned the day before is being consolidated into long-term memory.
Also wir sehen jetzt auf diesem Monitor, dass die Gemeinde sich länger nicht bewegt hat und deshalb schläft. Und zwar zeigt er ganz starke, langsame Ausschläge, dass diesen Charakteristik für den Tiefschlaf. Die Befunde zeigen, dass das gerade wichtig ist für die Gedächtniskonsolidierung. Dieser Studie ist es eben, diese langsame Oszillation zu verstärken, und zwar mit den Tönen, die wir dann in der Nacht geben. Jetzt mal. Genau jetzt haben wir gesehen, dass diese Geräusche genau in diese Wellenlänge übereinstimmen und dadurch halt weitere langsame Oszillationen auslösen. Man kann sich das vorstellen, dass das Gehirn wie eine Schaukel ist, das in der Nacht sehr stark hin und her schwingt. Und das Leben macht uns, dass wir genau im richtigen Moment, also genau wenn die Schaukel oben ist, die Schaukel in die richtige Richtung anstupsen, dass sie weiter schwingt und länger schwingt. Und dadurch werden die Prozesse der Gedächtniskonsolidierung, das heißt sozusagen die Reaktivierung der Gedächtnisspuren im Hippocampus und deren Transfer in den Neokortex, dadurch nochmal angestupst bzw. verstärkt.
The subject is tested right after getting out of bed. The exercise is to remember the pairs of words learned yesterday. On average, a normal person comes up with 15 out of 80 of the pairs. But when boosted by the sound pulse, the score goes up to 25 pairs. A significant improvement that paves the way for more impressive manipulations.
Darauf läuft diese Forschung hinaus. Ganz gezielt Gedächtnisinhalte verändern. Wir können auch Gedächtnisinhalte löschen, überschreiben mit dieser Methode. Das geht auch. Die Quintessenz ist aber die, wir können manipulieren Gedächtnisinhalte im Schlaf in einem Zustand, in dem der Mensch tatsächlich wenig Kontrolle über sich oder gar keine Kontrolle über sich hat.
Whether in flies, mice, or even humans, the manipulations performed in laboratories have already helped us understand how our memories are created, the way our neurons function. The enigma of memory is still not resolved, but couldn't these findings help us cure certain disorders, such as the problem of post-traumatic stress? To explore this question, we return to Pascal Roulet's laboratory. He has used the reconsolidation window to hack into the brain of a mouse and erase a memory. To take away a mouse's memory, a sophisticated experiment is required. Placed in a pool, it learns to locate a platform, the only place for it to rest. The next day, placed in the pool again, it immediately finds the platform, so the lesson was easily learned.
L'expérience consiste alors à injecter au bon moment dans le cerveau de la souris une substance qui va bloquer la reconsolidation. Le souvenir n'est pas reconsolidé, il va rester fragile et la souris va perdre ce qu'elle a initialement mémorisé. Tout se passe comme si on avait effacé sa mémoire.
The result is that thanks to this injection that disrupts neural activity, the mouse searches for the platform again, as if encountering the pool for the first time.
C'était une surprise parce que ce phénomène de réactivation de la mémoire, reconsolidation de la mémoire, était quelque chose de très fort. Donc, ça nous a obligés à revoir nos théories sur la mémorisation, donc la remise en mémoire au niveau hippocampique, au niveau cortical. Et puis, ça a ouvert énormément de portes en disant si on peut agir sur la mémoire, si on peut refragiliser un souvenir, même s'il a 10 ans, est-ce qu'on ne peut pas agir dessus dans certaines pathologies?
They set their sights on post-traumatic stress syndrome. Those who suffer are prisoners of their own memory, overwhelmed by feelings and emotions that resurface incessantly. Their memories are toxic, out of control, resurfacing against their will and poisoning the present.
Tout est soufflé autour de moi. Je perds conscience. Puis je reviens à moi. J'ai peur de mourir.
The victims of the AZF factory disaster in 2001 are still haunted by the memory of the event.
Un nuage jaunâtre qui pique les yeux et la gorge recouvre la zone où je me retrouve.
Some are treated by the department of Philippe Biom, a psychiatrist specializing in post-traumatic stress disorder.
Je vois un ouvrier qui pend dans le vide à la hauteur d'un étage. Son bras est coincé dans les blocs de béton. Il hurle. Je ne peux rien faire pour lui. Nous avons un cercle vicieux qui s'installe, des souvenirs intrusifs, diurnes et cauchemars, des comportements d'évitement, les cognitions négatives qui s'installent avec la perception mauvaise de soi ou du monde. Je suis nul, j'ai pas su faire face, j'ai pas pu m'en sortir, c'est à cause de moi ou c'est à cause de lui. Vous ruminez sans cesse les sentiments de peur, de honte, de culpabilité. Quand ça dure depuis au moins un mois, vous souffrez d'un état de stress post-traumatique.
But even to get rid of a toxic memory, there's no injecting a substance directly into the patient's brain like with the mice. The solution? Propranolol, a commonly prescribed drug that relieves stress and lessens the emotional impact of an event. Absorbed during the reconsolidation window, it neutralizes traumatic memories. This patient, victim of a car accident in 2012, is part of the clinical trials.
Donc le protocole consiste à faire venir la personne au centre d'investigation clinique. On demande au sujet de rédiger sur une page, à la première personne, au présent, l'histoire, le scénario
de son expérience traumatique, de son accident, de son agression, de la catastrophe où il a été victime, au présent, à la première personne, avec un maximum de détails contextuels, émotionnels.
With each new session, the patient takes propranolol just before revisiting the traumatic memory.
Les pompiers me demandent où j'ai mal. On met une couverture sur moi. J'ai mal au genou car le tableau de bord me tombe dessus. Ils découpent mon blouson et mon pull pour me prendre l'attention. Ils doivent me désincarcérer de la voiture. Je ne suis pas bien, j'ai froid. Oui, j'arrive pas à passer ce cap de culpabilité comme on m'avait dit que je ne sois pas culpable. Il faut que je me secoue la tête que je suis responsable. Et ça, c'est un cap que je n'arrive pas à passer.
Est-ce que vous avez le sentiment que c'est moins envahissant, que ça déborde moins, que ça s'impose moins à vous?
Oui, mes crises de larmes, c'est un peu atténué. Au revoir et bonne journée.
Merci, au revoir. Merci, au revoir.
Au revoir.
The treatment includes 6 sessions. The patient must still complete 2 more.
Il ne faut pas croire qu'on efface les souvenirs, on modifie la charge émotionnelle négative du souvenir pour en faire un souvenir de la vie quotidienne, ressemblant au souvenir de la vie quotidienne, et non plus intrusif parce que chargé d'émotions et de sensations physiques.
At the end of the clinical study, the patients will all be assessed to verify the effectiveness of the approach. But the first results obtained with the victims of the AZF disaster are promising.
Voilà.
Il y a 8 victimes qui ont bénéficié de ce traitement à Toulouse et il y en a 7 sur 8 qui ont guéri. C'est-à-dire que c'est des gens que nous avons suivis jusqu'à 6 mois après la dernière séance de traitement et qui 6 mois après n'étaient plus symptomatiques ou avaient des symptômes inframorbides, avaient des souvenirs de l'événement mais qui n'étaient pas morbides dans le sens où l'état de stress post-traumatique est morbide.
The idea of neutralizing memories, reducing their emotional charge so that anxiety is reduced, is gaining ground. The victims of the Paris attacks in November 2015 are also benefiting from this experimental treatment of post-traumatic stress. But the potential to manipulate memory paves the way for even more amazing possibilities. Hidden in the congested pathways of the brain are forgotten memories, neglected or even lost due to an accident or Alzheimer's disease.
So if we take letters or words as an analogy for memory information storage, a storage deficit where memory is completely lost would be analogous to a book being burned. You're never going to get that information back. But in a library situation, you can imagine a scenario where the book is somewhere in the library, but you don't know where it is. You don't know how to find it. So it's not that you've lost the information, but you've lost the index, you've lost the library index. How do you find that information? So the question is, how can we identify lost memories in amnesic subjects, and how can we find a way of actually retrieving them for those people?
At the famous MIT lab, they were able to accomplish a feat, getting mice with Alzheimer's disease to recall lost memories. Thanks to a new technique using a flash of light from a laser, Susumu Tonegawa is able to control neurons and juggle memories. A discovery that could earn him a second Nobel Prize.
With the optic fiber implanted deep inside the brain, and go to those cells which were activated during training, during acquisition of the memory, and illuminate blue light there. And these cells fires, okay, deactivated. And that alone is sufficient for animal to recall that specific memory.
He uses a technique that's an incredible combination of genetics and laser technology, optogenetics. It starts with a special seaweed in which they locate a gene that makes a protein that functions like a solar panel. It transforms light into electricity. Then, the gene is transferred into the region of the brain where memory is formed. Using genetic manipulation, only the neurons involved in what the mouse has just learned end up with this foreign protein. A flash of light is all that's needed to activate the neurons and recall that memory, and that memory only.
My student discovered that if you label the Abraham cells of the early Alzheimer mouse, and then you use the blue light trick to illuminate those cells, then the whole full set of memory comes out. In other words, these mouse in the early stage actually still have a memory, because although natural recall cue cannot retrieve the memory, you can retrieve it by artificial method of optogenetics. It is incredible that it works.
Optogenetics doesn't apply to humans just yet, but we can expect this technological revolution to tackle the problem of our lost memories someday soon.
In order to be able to do something about a clinical case of amnesia, we need to be able to first identify where the supposedly lost memory was, what brain cells might have contained the memory before the patient lost that memory. In the laboratory setting, we're there before the mouse learns the experience. We're able to know where that memory went to. But the challenge will be that exactly, how do we find those cells? And we're not currently at the stage of doing that. But we just have to imagine a way of doing it. Just because we can't imagine something today doesn't mean it won't be possible in the future.
It will be years before the newfound knowledge of our neural mechanics can be used to retrieve our lost memories. As troubling as it may be to learn about the unreliability of our own memories, the discovery that they are malleable opens up new horizons for the exploration and mastery of the brain's shortcomings.